All right, today we're going to be looking at the last situation where you can use the law of sines. It's the side-side angle situation. So you are given the length of two sides and a non-included angle measure, okay? And the reason this is called the ambiguous case is that based on your givens, there is the potential that they could form one triangle, two triangles, or no triangle at all. Just in general, the word ambiguous can have the meaning that it could lead to two or more possibilities. Okay, so let's illustrate what I mean here. All right, so in this applet, I have the side-side angle situation at play. So we're given the measure of side length A to be 3.87 units right now. Side length B is 1.39 units right now, and then I'm also given the measure of angle B, 35.19 degrees. So notice this is the side-side angle situation. And right now, these parameters, they don't lead me to a triangle, okay? Basically what we have here is side length B, it is not long enough in order to create a triangle here. In order to create a triangle that has that angle 35.19 degrees. Now, I'm going to increase the value of that side length. You can see as it increases, I'm getting closer and closer to getting a triangle that has the given parameters. Once I get it to exactly 2.23, notice it says the number of triangles is one triangle. And that's specifically a right triangle here. So there's one possibility. If I continue to increase the value of B, now notice I end up with two possible triangles. Okay, one of those triangles you would have an acute angle, so that would be the triangle BEC, where the measure of angle E here is acute. And then the other possibility is triangle BDC, where the measure of angle D is obtuse. Okay? And you'll notice if I continue to increase the value of B, then at this point right here, now I jump back to only having one triangle possible. In this case, it would be an acute triangle or an acute angle at angle E. All right, so those are the possibilities that can come up based on the givens that you start off in the side-side angle situation. So I have a number of examples to help drive this all home. So let's look at example 3 here. I'm giving us that the measure of angle A is 30 degrees. Let's draw that in. Side length B is 10 units, side length A is 5 units, and we're asked to find the measure of angle B. So this is that side-side angle situation. Two sides and a non-included angle have been given. The law of sines can be used then. Sine of 30 degrees divided by the opposite side length of 5 equals sine of angle B divided by the opposite side length of 10. Go ahead and cross multiply here. 10 times sine of 30 degrees equals 5 times sine of B. Okay. Now 30 degrees is a nice angle to use here because sine of 30 is 1/2. I have 10 times 1/2 or 5 here. And now I can divide the 5 over. 1 is equal to sine of B, and that means B is equal to the inverse sine of 1, which is exactly 90 degrees. So what we're working with here is one right triangle arising from these givens. So even though I had the initial picture drawn to look like angle B was acute, it turns out that it's actually a right triangle that looks more like this. 10, 5, 30. Okay. All right, example 4. Oops. This time I have angle A is 30 degrees again, side length B is still 10, but I increase the value of side length A to 6 units. All right, law of sines, sine of 30 degrees divided by 6 equals sine of angle B divided by 10. 10 times sine of 30 equals 6 times sine of B, or 5 equals 6 times sine of B. B is going to be equivalent to the inverse sine of 5/6, which you're going to need a calculator for. Okay. Inverse sine of 5/6 is going to yield a first quadrant angle of 56.4 degrees. Okay. All right, now keep in mind, the inverse sine function, it only yields angles in quadrant 1 and 4 by its range, but sine is also going to equal a positive ratio of 5/6 in the second quadrant. So what I need to do here is take this 56.4 degrees I just got and treat it like a reference angle in quadrant 2. So I'm going to subtract it from 180, and that gives me another possibility for the value of B, 123.6 degrees. Okay, so you always want to check that second quadrant version as well. All right, now just because I got two values here doesn't mean I can keep them. I have to check both of them with the original angle that was given to start off the problem. So in this case, we were told that A was 30 degrees right off the bat, right? So I have to make sure that the values that I just found for B, that when I add them to 30 degrees, they don't exceed 180, okay? Because we know that the sum of my angles in my triangle, they can't be larger than 180 degrees. So if I add 30 degrees to this first quadrant angle for B, I end up with 86.4 degrees. It is definitely possible for the two angles of my triangle to add up to 86.4. If I do the same thing here with the second quadrant value for B, I end up with 153.6 degrees, which is still less than the maximum allowable number of degrees in 180. So both of these angles can be possible. For the measure of angle B, I'm winding up with two triangles here. All right, so the first triangle would look very similar to the picture I have drawn up above, where A is 30 degrees and B is an acute angle of 56.4 degrees. And this is, of course, that's 10 and this is 6 here. The second triangle possible would have angle B as an acute angle. It would look more like this. And angle B is now this 123.6 degrees. Okay. All right, example 5. Now I decrease the value of side length A to being 4 units. So still 30 degrees for A, 10 units for B, and now 4 units for A. Sine of 30 degrees divided by 4 equals sine of angle B divided by 10. 10 times sine of 30 equals 4 times sine of B, or 5 equals 4 times sine of B. And B is going to equal the inverse sine of 5/4, which you can punch that into your calculator if you want. You're going to get an error, though. There is no solution to that because in the fraction of 5/4 you have a larger y value than you do an r value. So this would be a case where, based on these givens, no triangle is possible. basically the side length of 4. It's not long enough in order to create the other two givens of 30 degrees and a side length of 10. Okay? All right, one final example to drive this all home. Completely change up the givens here. Use the law of sines to solve the triangle, which means find all the missing measures. So we're given A again, 40 degrees this time. A is 3, B is 2 for the side lengths. So let's start off by trying to find angle B here. See if we get 0, 1, or 2 triangles possible. So we'll take sine of 40 degrees divided by 3 equals sine of angle B divided by 2. Okay. I'm going to cross multiply here. 2 times sine of 40 equals 3 times sine of angle B. Not going to really be able to simplify the left side like I was able to on the last 3 examples, right? Sine of 40 degrees, that's not going to be an integer, so I'm just going to leave that as is. I'm going to divide the 3 over, and then I'm going to be able to say that B would be equivalent to the inverse sine of 2/3 times sine of 40 degrees. Okay, and that would definitely be calculator work. Okay, so inverse sine 2/3 times sine of 40, 25.4 degrees, which is clearly a quadrant 1 angle. Okay, now let's make sure that we can keep that angle. If we add it to the original measure that we were given, which was 40 degrees, that is going to give us 65.4 degrees. Okay, so the two angles, angle B and angle A, are adding up to less than 180 degrees. That means I can definitely keep this value for B. Let's consider the second quadrant possibility, though. If you take the 25.4 from quadrant 1, subtract it from 180, you end up with 154.6 degrees in quadrant 2. Okay. All right, now check that with the given 40-degree angle for measure of angle A. That's going to be 194.6 degrees. Okay. So what we have here is we have two angles in our triangle are adding up to larger than 180. That is not possible. It can't exceed 180, right? So that means that this second angle can be ruled out. So we're only working with one triangle here. Okay, one triangle. So let me draw it. Okay, so this was 40 degrees, and then what we had 2 here, 3 here, and now we can say that this is my 25.4 degrees. All right, so two unknowns left to find. We're going to find measure of angle C next. That's nothing more than taking 180 and subtracting it from the sum of the two angles that we already have. Right, which we know that that's 180 minus 65.4 degrees. Okay. 114.6 degrees right here. Okay, and then let's go after side length C to finish off here. We can use law of sines one more time now. So I'm going to set it up sine of 40 degrees divided by 3 is equal to sine of 114.6 degrees divided by side length C. I'm going to cross multiply here. 3 times sine of 114.6 is equal to c times sine of 40 degrees. I'm going to divide both sides by sine of 40. Those wipe out. And let's see what we get here using the calculator one final time. 3 sine of 114.6 divided by the sine of 40 degrees. 4.2 units. 4.2 units. Okay. All right, there you have it.